Hello, Advanced Algebra students. Welcome back to another video lesson. Today we're going to dive into Chapter 5, Lesson 1 on inequalities in compound sentences. Compound sentences being kind of the newer piece to this information. We're really looking at, can you write, solve, and graph linear inequalities? The key here being inequalities, where we've done a lot with equations last week, leading in the week before. So now we're going to jump into these inequalities. Before we do that, I just kind of want to give you an overview of where we've been and where are we going. So we did solve systems, and a lot of this is still about solving systems. Part 1 was solving by graphing substitution and elimination, which you did a mini test on. Part 2 now is all about these inequalities and looking at how to solve inequalities in one or in systems. And so that's really kind of where we're introducing this concept today. So what do we remember about something that looks like this? Solve 2x is greater than 12 and then graphing it on a number line. The nice part about many of this section is that we're still solving the same way. Dividing both sides by 2. And because we divide by a positive number, nothing happens to the inequality sign. And I've got x is greater than 6. X is greater than 6, which means I need to graph that on a number line. So here's my number line, and I'm going to put x on the end because we're talking about an x variable. And we're just going to talk about the numbers 4, 5, 6, and 7 on this number line. 4, 5, here's the 6, and here's the 7. And when we graph these, we're trying to show all of the possible answers that would work for the value of x. In this case, x is greater than 6. So we're going to use an open circle at 6. Okay, we'll talk a little bit more about why it's an open circle on the next slide, but an open circle. And where are all of the numbers going to be greater than 6? When I plug something in here, it has to make this a true statement. In this case, anything over here to the right. X is greater than 6. So that's how we did it when we were in algebra class, graphing or solving inequalities and using a number line to graph their answers. Now, we're going to follow some of the same concepts with what we're doing, but now we're going to talk about compound sentences that have these two words called and or the word or. Okay, these are some very important notes and steps that you're going to want to have written down. I can't stress that enough. We're going to go through some examples on the bottom of this slide as well. The more you write down, the more you practice these, the easier they're going to become. So to graph inequalities, right now this slide is just all about graphing inequalities that have and or the word or in them. We're going to draw a number line, and we're going to plot the endpoints, meaning 5 and 3 in this case might be our endpoints. And then we have to determine whether we're going to use the solid line or a solid circle, I should say, or an empty open circle based upon whether or not the equal to bar is there. Right? Remember the equal to bar, and I'm going to go back a slide for a moment. The equal to bar here would mean that 6 is part of the solutions. It could be 6 or it could be anything greater than 6. In this case, it has to be greater. So we leave it open because 6 is not part of the answer set. And that's what this point here and here is talking about. If it is part of the answer set and it's included, then we make sure that we fill in the circle. If it's not included, because there is no equal to bar, then it's just an open or an empty circle. We will graph one of them. We'll graph the first one, and then we'll graph the other one. And then what we have to do is be aware whether or not we're working with an and equation or an or equation. Okay, an and is very specific. Okay, and means both, right? It has to satisfy both. So we would be looking for an overlap. But the and signifies that it must meet both inequalities. The or compound means one or the other. One or the other. It does not have to fit both. It just has to fit one or the other. So let's look at these examples down here. Okay, number 1. First step, draw a number line. So I'm going to draw this number line like this. Put arrows showing that it's a number line. This number line is labeled X. My endpoints. So here's the number 3 on the number line. And be careful, right? Even though number 5 came first, make sure you set up your number line properly. 3 and 5. I'm going to graph this one first. X is greater than 5. Open circle because 5 is not included. Greater than is to the right. X is less than 3. That's this way. Less than is an arrow to the left. And now, because it was the word or, I don't have to look for the overlap. It's one or the other. So ironically, that one is done, right? It's just simply done because we're showing the answers could be here and less, or they could be here and greater, right? Less or greater, either way. And so we're kind of looking at them with the or versus number 2 where we have the word and. All right, let me do number 2 in just a different color. Let's just choose, let's choose the black. Here's my number line, kind of sloppy. This time I want to make sure that I label it with a T because we're now using the variables T. Okay. One number is -5. The other number is 3. T has to be greater than or equal to -5. So now we would fill in our circle here. Okay, so we put a circle, but we're going to have to fill it in as best as we can. And it's greater. So everything that way. T is less than 3, so it's open, and it's everything that way. But what we're looking for is the overlap, or where both of them are included, right? Because the answers have to fit for this one, and they also have to fit for T is less than 3. They have to fit for both, which is more or less this little subsection here to here, which means I have a closed circle at -5 all the way up to an open circle at 3. Open circle because a 3 does not work for the second one. Okay, so we look for that overlap, and then that's what we draw up above the graph to show where the overlap or where the and fits for both of them. Next slide. All right, working backwards. How do I write then? How do I write the inequalities? Okay. Usually, we just have to make sure we're looking at the circle type. We know what variable they're using on the end. And then, is this an and or is this an or statement that we're connecting them with? Usually, when we have an arrow going in both directions, like we do in number 1, this is typically an or statement. Sometimes it might be an arrow just in one direction going on forever. Whereas we have 2 distinct endpoints and the graphs stop, this would be more of the and statement. So let's look at number 1 and see if we can't figure out how to write this. All right. Here, M, and the arrow, we're comparing it to 3. All of these numbers here are less than 3. So the variables have to be less than 3. Do I put an equal to bar? No, because it's an empty or an open circle. Then I'm going to use the word or. And I'm going to compare M and 6. Here, the arrow is showing all the numbers, or M has to be greater than 6. But in this case, because it's a filled-in circle, it's also equal to. So this would be our answer for number 1. Number 2. Okay, now we got a K. So here I've got K compared to the number 2, right? Compared to number 2, everything has to be greater. So K has to be greater or equal to 2 because of the filled-in circle. Because we've got an overlap or 2 distinct endpoints, it's the word and. And then the second one is comparing K to 4. All of those values have to be what compared to 4? Less than. In this case, or equal to 4 because of the closed circle. So we're trying to go backwards and take the graph and write those inequalities to show what's being represented. Now, the last thing that leads us into what we're doing for the rest of this chapter here, though, is can we solve inequalities and graph them, kind of like we did on the front example, that front warm-up slide. Okay, we're going to solve all of these like we have been solving normal equations. Add, subtract, multiply, all of it. There's only one exception, and it's here in red. If you multiply or divide by a negative number, You multiply or divide by a negative number to both sides. It's the important concept, to both sides. And it's only multiply or divide. Then you must flip the sign in the other direction. Both sides. Okay, I'll show you an example of that down here. Scale and label your number line, and then you graph it. All right, scale and number. So if we're trying to solve this, take a moment and solve it and see what you get. Okay, hopefully you subtracted 5. You got negative 7x greater than or equal to 21. And then you're going to divide both sides by that negative 7, the coefficient. Now, this is what we're talking about up there in red. We divided both sides by that negative number. That means that x, I have to reverse or flip the sign the other way to negative 3. X is less than or equal to negative 3. And now we have to make sure that we graph. There's my number line with an arrow on the end. Arrow on the end. This is still x, so we're going to label it with an x. Here's the negative 3 value. And we have to interpret the answer. X is less than or equal to. So the equal to means a filled in circle. Where is everything less? What answers would fit? Anything going that way. So a lot of different steps and components to what we're doing today, but we're going to use a lot of this as we move forward throughout the rest of chapter 5 here and the rest of this week. So if you have any questions, make sure that you reach out. You've got a few practice problems in the packet to try today. Otherwise, until our next video, everyone, stay safe.